This is what you will be facing in your double asymptote Aleks assignment. And it's important that we start by factoring things out. So if you're given this much, so if you're given a function that looks like this, I would suggest that you start by factoring the function. Here you could have 3 times x plus 1 divided by, and let's find those two binomials. So x and x. And we're looking for something that gets you minus 12. And if you multiply those two numbers and when you add them, you get positive 1. So it looks like we might be dealing with 4 and minus 3. Looks like that will get us there. So if you look at the numbers that we have, the vertical asymptotes that we're going to be looking for are x equals minus 4, and the other one will be x is equal to 3. And from the options that we have here, x equals 3 looks like this is x equals 3, and this is x equals minus 4. So option A might be still in contention. Graph B, we have 3 and we have minus 4, so graph B is still in contention to be g of x. Looks like those asymptotes are nowhere near what we want to find. Graph D doesn't make it. Here we have minus 4 and 3, so graph E might still be an option. And graph F does not make the cut. Now, if you look for the other two important aspects of the graphs, you're gonna need the x-intercept. So x plus 1 equals 0. That means that x is equal to minus 1, making your x-intercept minus 1 comma 0. So out of the options that we have on the plane, here we have coordinate minus 1 comma 0, minus 1 comma 0, and this one is crossing 2 point something. So now graph E is out of contention. So we are gonna say goodbye to graph E. Now, still in contention, we have graph A and graph B, and I think it's gonna be down to the y-intercept, meaning we're gonna evaluate the function with 0. So 3 times 0 plus 3 divided by, we might use the unfactored version. That means we're using 0 squared plus 0 minus 12. And we get 3 over minus 12. So the coordinate is negative 0 comma. Looks like we're gonna come down to minus 1/4. So let's look for a graph that crosses the y-axis at a negative place. So this one is positive, this one negative. So the one that covers all the bases is graph B. So this is our winner. You are g of x. So now let's find who is h of x. If you want to be completely fair with the graph, you would perhaps evaluate with, you would find f of 4, you would find f of perhaps minus 5 or minus 6, f of minus 3, f of 2. So that would be a fair assessment at the end to see if that is actually graph A. But I think that's enough information. That's enough to tell which is which. Now let's move on to h of x. So if you have h of x, I'm going to rewrite h of x as 3 divided by one quick observation on that g of x. I did not find the horizontal asymptote. The degree, the winner is x squared. So that means that the horizontal asymptote should be at y equals 0. And that actually makes sense with the selection. Y equals 0 is exactly where the horizontal asymptote is. So that means that graph E wouldn't even be considered to be in contention since the horizontal asymptote is y equals 2. So this one was not even an option. The only two options were in reality graph A and B. Now let's use h of x, and we're going to factor it out as x times x some minus or plus something times another combination of terms. So it looks like we're going to need an x plus 1 and an x minus 2, having our asymptotes are at x equals minus 1 and x equals 2. So in contention, we have minus 1 and 2. So we have graph C in contention. We have graph D also in contention, and it looks like graph F will also be in contention at the moment. And one of the deal breakers is going to be the fact that the greatest degree is in the denominator. So our horizontal asymptote is at 0. And that's the case for graph C and graph D. So now graph F is no longer in contention. So we're going to stick with the ones that are congruent with what we're getting. Now, there is no x-intercept since there is no x in the numerator. So the thing with that is that we are not going to be crossing the x-axis, and this one is crossing the x-axis at 0, 0. That is breaking the rules. This one does have an x-intercept. So looks like it's going to be graph D, but just to be perfectly safe, I'm going to find the y-intercept, which is 3 divided by 0 squared minus 0. It's not going to make a difference, but let's fix that. 0 and then minus 2. We're going to end up with minus 3 halves. So the coordinate would be 0, minus 3 halves. And looks like that's the case. So graph D are in reality function h of x.